So here let us record some facts which arise from the universal coefficient theorem. So first let us write down the sequence which comes from the universal coefficient theorem. You start with the extension group, then you go to the cohomology group, apply map H, and you end up in the dual of the homology group. Now if the homology groups Hn and Hn minus 1 are finitely generated, let us write this down. Hn and Hn minus 1, these homology groups are finitely generated and they have torsion subgroups. So Hn has torsion subgroup Tn, Hn minus 1 has, so let me write this down, torsion, so it is clear, and Hn minus 1 has torsion subgroup Tn minus 1. Now you have seen this, that because we take this as co-kernel, the torsion comes in here. We showed this on the previous slide, it was G over Ng. When you take the home, what remains is Hn modulo the torsion. So the torsion does not come in picture when you take the home. So therefore, what is HNCG now? So HNCG is just the direct sum. So this is important for computing the cohomology groups. So using this formula and the properties of X we described before, you can start computing cohomology groups of CPN, RPN, torus, etc. So consider this chain map. Now let us move further. Consider this chain map. And we want to construct a map arising from the universal coefficient theorem for these two chains. So since we have this chain map, we can always talk about the cohomology groups, just like we talked about homology groups of these chain maps and the link between them, which we said was the naturality condition. So replacing homology by cohomology groups and then breaking that long exact sequence into these short sequences, we can naturally form the following chain. So the first chain of co-ker I star n minus 1 to cohomology group to kernel of I star n is related with chain complex C, and the bottom one is related to chain complex C prime. Now let us draw the natural maps which come from alpha. Again this is nothing but the naturality condition. You just have taken the long exact sequences associated with two chains and then constructed natural maps between them, and then you have broken them into short exact sequences. So immediately this above implies the following. This we have seen multiple times. So again the exact sequence which I am drawing right now is associated with chain complex C, and the bottom one would be associated with chain complex C prime. So now I am writing the short exact sequence associated with chain complex C prime, which essentially comes from the universal coefficient theorem. So this chain complex is probably important in some applications, but immediate application of this is the following, that if there is an isomorphism within the homology groups, yeah, so if there is isomorphism, so a chain map, say alpha, from one chain complex, say C to C prime, induces isomorphic homology groups, then this immediately implies by this ladder between the universal coefficient theorem chains, that is extension of hn minus 1 c comma g and then extension of hn minus 1 c prime comma g. So the last two rows or the last two commutative diagram. So this immediately implies that if a chain map induces isomorphism in homology groups, then it will also induce isomorphism in cohomology groups. Yeah, so this is the consequences of 5 lemma, and this map in the middle is the isomorphism. Yeah, you can see the 5 lemma comes from the 5 terms: 0 to extension to cohomology group to dual of homology group.